For most of us, our introduction to the Arduino world is ripping open a starter kit and cobbling a few pieces together, typing in some code similar to what you see on your screen, hitting upload, and for the first time, watching an LED blink. And the example code that we're often given is to write the LED high, delay for a second, write the LED low, delay for another second, and repeat until the world comes to an end. As you move on, you are able to write more and more code, and maybe you're reading a temperature sensor and adding some buttons. Eventually, you will come to the point where you realize that you can do nothing else during this 1 second delay. So in other words, if you are trying to read a temperature, you can't read that temperature during this 1 second. If you are trying to push a button, you can't read that button during this 1 second delay, and that becomes a problem. So you go to the forums and you go to the Facebook groups and you ask them, and somebody will just hastily reply to you, try the blink without delay sketch, which you can find here under examples and digital blink without delay, and you get this sketch, and it's got some comments in there, and I think they did a good job of explaining it, but it's just not very intuitive to someone who doesn't understand how it works. So I thought we would take a few minutes today and go through how it works and sort of step through the process. So I'm going to bring up some code, and we're going to take a look at some different examples, and we're going to kind of step through some different loops and blinking things. And as you can see, I have an LED hooked up. I have 3 LEDs hooked up, and as I enter this code, you're going to see what happens over at the bench. So right now we're looking at the example code. You're turning LED on, off. Now just for the heck of it, we're going to expand this code a little bit and blink all 3 of these LEDs just to make sure that the circuit is good, make sure that we have enough power to blink all 3 LEDs on or off. We're turning on red, green, blue, all of them on for a second, all of them off for a second, the same exact problem we had in the last one. So now what I want to do is I want to get to the concept of blink without delay, and it is all about this function called millis. And when you look at that big example script that they give you, it may not be really clear what's going on. So what we're going to do is we are going to load up this simple sketch that I wrote here, and all of these sketches are available on my GitHub. I will post a link to it, but we're on sketch 3 here. So I'm going to copy this over and we're going to upload it. And then this time we're going to upload the serial monitor, or we're going to open the serial monitor, and you're going to see that when the thing boots, it says current millis is 0. And essentially what happens is when the Arduino boots up, it starts a stopwatch, not a clock, a stopwatch. It doesn't actually know what time it is, but it will go on and count from the minute it finishes its setup, from the millisecond it finishes its setup, it begins counting. And as you can see, what we're doing here is every single time we go through the loop, we are setting this variable and we're printing it out. And then in our case, we're delaying 5 seconds. Now you just saw something interesting happen here. This went up, it was counting up nice and neat by 5,000s, and then all of a sudden it begins to drift just a little tiny bit. The reason for that is because it actually takes a little bit more than a millisecond to go through this loop. And so every single time it goes through the loop, it's counting, and it just happens to drift by about 3 milliseconds over these first 60 seconds that we went through. But that's not really that big of a deal when we're talking about LEDs and things like that. The point is, and this is what you need to understand, this millis function right here is always from the time the Arduino booted. And so we can grab that number at any time in our sketch and find out how long has your Arduino been booted, and it will count up to just under 50 days. And then at 50 days, it's going to start back over at 0. And that does complicate things a little bit, but we're going to talk about that. So just understand that you always know how many milliseconds the Arduino has been booted for. So we're going to close this, and we're going to go to our next sketch. And we are going to blink an LED without using the delay command. So I'm going to upload this code, and then I'm going to explain how it works. So let me make sure it actually starts blinking. were uploaded, and the red LED is blinking on 1 second and off 1 second. Now this code is definitely more complicated. I definitely could have written it cleaner, but I want it spread out so you can see exactly what's going on. So the first thing we have our red LED, and then the next thing we have is the interval that we want the red LED on. Now that used to be delay 1000, but we're actually setting that as a variable, and you'll see why in a minute. The next thing, and this gets kind of interesting, we are recording the last time the LED turned either on or off, and that is in reference to how long the Arduino has been booted. So let's just say, for instance, it starts off at 1000 milliseconds, it will turn on. At 2000 milliseconds, it will turn off. At 3000 milliseconds, it will turn on. And so from the time the Arduino booted, we want to know the last time it made a change. And then just for the heck of it, we are going to start with our LED off. So what happens in the loop? We are creating an unsigned long variable. And what that is the one that can count up to basically 47 days. But we are making it unsigned, which for one thing allows us to count twice as high as if we were doing signed. But even more importantly, it makes it impossible to get a negative number. And because of that, that will help the math to still work. And this might be a little bit confusing, but that will help the math to still work when millis loops over at 47 or 49.7 days. Just trust me on that. We're not going to spend a lot of time on that part. But it is an unsigned long variable, and every single time we go through the loop, we are counting millis, just like we were doing before. 5,000, 10,000, 11,001. We are counting those millis. So what we want to have happen is every single time we go through the loop, we are going to check if current millis, whatever reading it got, minus the previous time that the LED was cycled, is greater than the interval. So let's just write this out for a second. So let's say that we boot at 0 seconds and our interval is 1000. So we start off with previous red is 0. So we have our current millis is 0, our previous red is 0, our interval is 1000. So this current millis minus previous is not greater than the interval. So we're going to do nothing. Now it might go through at 100, 200, 300. Eventually, this Arduino will have been booted for more than 1000 milliseconds. And so at the 1 second point, it's going to say, oh, okay, great. So we are greater than 1000 milliseconds. So what I want to do is I want to save this time. So we're going to say, all right, great. We hit 1000 milliseconds. So that is our new previous time. And if the LED was low, we're going to turn it high. If it's high, we're going to turn it low. We're going to write the LED and go on. And so I want to make sure you understand what's going on here. Every single time the Arduino goes through the loop, thousands of times a second, it will check, has the LED not changed state for longer than this interval. So it's going to say, all right, current time is this. I changed last time at this. Is the difference between these two times more than the interval? If it is, flip the LED. And that's exactly what we're doing. Now, the thing that makes this magical, yes, it's a lot more code. Yes, it's a lot more complicated. But there's nothing in this sketch that stops the Arduino from doing anything else. If you're reading temperatures, if you're looking for button presses, if you're looking for anything, it's going to loop through as fast as the Arduino will possibly go and continue looking, and only execute this chunk of code if the right interval has passed. So I hope that makes sense. So what we're going to do, in case you're lost, we're going to do one more example where I'm actually going to put a delay in here that's going to throw off the blink, but that's okay because I want you to see what happens. So we're going to paste this and I'm going to upload it, and we're going to go back to the serial monitor. And I'm just going to grab a chunk of this code. Okay, and I'm going to paste it right here. And we're going to stop looking at the serial monitor, and I'm just going to open up a new file, and I'm going to paste it. So what we have here is the current millis at this point is 1603, which means the Arduino has been on for 1.603 seconds. The previous time the LED had flipped was 0. In other words, when we first booted it. So what it's going to do is it's going to say, wow, that difference of 1603 is greater than the interval over here of 1,000. So therefore, change the state. And if you notice, the reason why there's such big gaps in here is I have a delay of 800 milliseconds slowing this whole thing down to make it readable. So now it goes over here and it says, all right, so last time it was read was 1603. Now it's 2408. So the previous state change was here. The difference is only 800. Well, that's not greater than 1,000, so don't change the LED. Now it's going to read it again. The difference is 1666, so change the state. And so you can see that it's just doing math every single time it goes through the loop to decide whether or not it should change the LED or not. And so we're going to do one last example. We are going to blink 3 of these things. And so I'm going to come in here and I'm going to paste all this code, and we're going to walk through this real quick. So what I've done is I've been super repetitive, which is not generally good coding practice, but I've got red and a red interval, blue and a blue interval, green and a green interval. And then what I did is I made very simple functions here. So check red is exactly what was in the loop before. Check green is exactly what was in the loop before, except every time it said red, I changed it to green. And check blue is exactly what was in the loop, except I changed it from red to blue. Now, what you can see here is that I have different intervals. So the red one will blink on and off at 1 second. The blue one will blink on and off every 2.5 seconds. And the green one will blink on and off every 5 seconds. And so even though these intervals are gonna crash into each other and all that kind of stuff, it's not really gonna matter. And then I just made the loop this very simple: check red, check green, check blue, and we're gonna upload the code, and you'll see that these LEDs are able to blink at different intervals without interfering with each other. And so the green one will just blink on and off every 5 seconds, regardless of what's going on with the other ones. And each one will go on its merry little way, not caring what the other LED is doing. Now, if you're like me, you would say something seems really weird about minusing the previous one. Wouldn't it make more sense to say every time you blink the LED, set a new variable that says turn off at 25,000 millis, and then turn it back on at 26,000. Wouldn't it make more sense to count up instead of subtract? And the reason why you don't do that is because of that rollover that happens at 50 days. This math right here will not break when that happens. If you were to try to say, hey, turn off the LED at this time, you could wind up screwing something up when that rolls over. And so this is the tried and true way to do it. It's not obvious, and don't feel stupid if it doesn't make sense to you. But I do encourage you to download these scripts, play with them, and just kind of see what you can do on your own. I hope I did a good job explaining this. I'm sure I could do a better job. Please let me know what you don't understand in the comments, and thanks for watching.